Hi everyone, welcome back. Let's write some more Leetcode today. Today we're solving valid anagram. I will go over 2 ways to solve this problem, but I will only show the code for the optimal solution. If you are only interested in the optimal solution, then feel free to skip to the desired timestamp. So the problem states that we are given 2 strings s and t, and if t is an anagram of s, meaning that these 2 strings don't have to be in the same order, but they should contain all the same letters. And if that is the case, then we return true. Otherwise, we return false. So how can we solve this? One way to solve this problem is that given the 2 strings we have, we can sort both of the strings, and if they are equal, then we know they are an anagram, then we can return true. Otherwise, if they are not equal, then they are not anagrams and we can return false. So let's go through this example. Let's sort both of these strings. This string will become AAAGMNR. And this string will become AAAGMNR. And since these strings are equal, then we can return true. So the time complexity of this problem will be O of n log n, because that's the time it takes to sort both of these strings. And the space complexity would be constant because we are not using any extra space. So even though this is a fairly simple approach, there is a faster way to solve this problem. The faster way to solve this is we can create a hash table for both of the strings, and the hash table can display the number of times each letter shows up in the string. And if both of the hash tables are equal, then we can return true. Otherwise, we can return false. So let's go through this example. So this hash table will have A show up 3 times, M show up once, G show up once, and N show up once. And if we look at this example, it will have A show up 3 times, M show up once, G show up once, and N show up once as well. And therefore, these 2 hash tables are equal, so we can return true for this example. The time complexity of this would be O of n, because we need to loop through the strings and form the hash table, and that would take linear time. The space complexity would be constant, or O of 1, because even though we are creating hash tables, these hash tables will not be longer than the length of 26 because the strings will only consist of letters in the alphabet. So now let's get to the coding part. Yeah, so first, if the 2 strings are not of the same length, then we can go ahead and return false, because there's no way they are an anagram if they have different lengths. Now we can go ahead and make a hash table for each string, which are basically the frequency counter of each string. So we'll call it count S and count T. So now we're going to loop through the 2 strings. So we can do it for I in range length S or length of T, doesn't matter because they have the same length. So we'll call count S of I, and we will add 1 to the letter of the frequency. So 1 plus count S get the frequency of S of I, and if it's not in the hash table, then it'll be 0. So 1 add to 0. And I'm going to copy and paste and put it on the next line, but switch S to T. So give me a few seconds. And let's change that to T and then count T. And now finally, we can just return if count S is equal to count T. And that should return true or false depending on if the hash tables are equal or not. Let's see if it works. Okay, great. Now a quick side note, we could have just used the built-in class counter, and we can return if counter of S is equal to counter of T, and that should work as well. However, I decided to write the longer codes because I feel like that will help us better with understanding. So yeah, thank you all for watching. I hope this was helpful to you guys. If you guys have any other questions or comments or concerns about the video, feel free to let me know in the comments section down below, and I hope to see you all again soon. Thank you.